So far in the problems, we've dealt with the magnetic flux changing due to the magnetic field decreasing or increasing. Now recall, flux is equal to B times the area, and changing flux is what generates our EMF. So we can either change the magnetic field or the area and generate an EMF. So how do you change the area? Here's a pretty simple case. You have a loop of wire here. It has a certain cross-sectional area exposed to the magnetic field. If I were to pull it apart, I now have a smaller area. So in this case, the area goes down, so the magnetic flux decreases. There's another way of changing the area in order to change the flux. It's a little more practical than the hand stretching it that we just showed. We can take a coil of wire here, put it on little pivot points here, and rotate it. When you do that, the flux through the area will decrease. We'll have less of an area exposed to the magnetic field. So we have the loop being rotated from being perpendicular to the field to parallel with the field. So the flux goes from a maximum to zero. We'll be covering this in more detail when we get to AP physics, where we worry about what happens between this perpendicular nature here to the parallel. But in both those cases, the area exposed to the magnetic field is decreasing, so the flux will decrease.